Okay, so this is definition 2. Chapter 2 starts out with definition 2. Well, definition 1 was in terms of x, y's, and r's. So it was all around the coordinate plane. We were in all 4 quadrants, right? And we found x, we found y, we found r. Remember, r is always positive, and then we found all of the 6 trig functions. Well, now we're going to just hang out in quadrant 1. Okay? This is probably more familiar for you because this is what you've done before. So if a triangle, ABC is a right triangle, with C being the 90-degree angle, then the 6 trig functions are sine is opposite over hypotenuse. This is your whole SOHCAHTOA thing. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And the reciprocals still apply. So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And cotangent is adjacent over opposite. So remember we had this whole thing that we did this. Well, maybe I'll do it here. So, TOA. Remember that? That's what we're doing now. Okay? It's still in terms of x, y's, and r's because we're in quadrant 1. Okay? Everything is now going to be positive. Some of you on your test told me that I said it was in quadrant 3, and then you told me all of the trig functions were positive. Or I told you it was in quadrant 4, and you told me all of them are positive. Well, that's an automatic -4. Okay? But the nice thing about these guys is now we are in quadrant 1, so they're all going to be positive. Okay, so let's look here at number 1. Number 1 says, find the 6 trig functions of angle A. Okay, so if I sit here at angle A, I can do my opposite, adjacent, and hypotenuse. But what else do we need before we can even start? We gotta find B, right? And how do we find B? Pythagorean theorem. Okay, here we go. 6 squared plus B squared is 10 squared. 36 plus B squared is 100. So B squared is 36, or 100 minus 36, which is 64. All right, now, so B, technically we're the one taking the square root, right? So technically it's what? Plus or minus. But we also have a triangle here going on. And we know we're in quadrant 1, so he's just the positive one. So B is 8. Okay, so if I'm sitting here at A, the one across the triangle is the opposite, so I'm going to give him an O. The one that touches, the leg that touches the angle, that's my adjacent. So I'm going to give him a big old A. Even though he's side B, he's still the adjacent one. And then the guy across from the right angle would be my hypotenuse. So there, I'm going to just label them O, A, and H. Hi, Griffin. Okay, so when it says find the 6 trig functions of angle A, well, here I go. I want sine. Theta stands for the angle, so I want sine of A. So I want opposite over hypotenuse, 6 over 10, which reduces to 3/5. Yes, we should reduce. We know how. All right, cosine of angle A. Adjacent over hypotenuse. Okay, well my adjacent is 8 over 10. Which reduces to 4/5. All right. Tangent of A. Opposite over adjacent. What else could we do? What else do you know about tangent? Sine over cosine, right? So it should match up. Opposite over adjacent would be 6 over 8, which reduces to 3 over 4. So those rules still apply. All right, it said to find all 6, so here we go. Cosecant. What do I have to do to cosecant? Flip over sine, so that guy's 5/3. Secant of A. Flip over cosine. 5/4. Cotangent of A. Flip over tangent. 4/3. Okay, now what if it didn't tell me angle A? What if it said angle B instead? Would those guys all be the same? No, because your opposite and your adjacent switch. Okay? So when you're placing a right triangle in standard position, there was a little trouble with that on your test, so standard position is right here. When you're placing a right triangle in standard position, angle A here must be an acute angle. Otherwise, you're no longer in quadrant 1. If you're not in quadrant 1, you have to use definition 1 with x, y's, and r's. Okay, now I want to show you something. So if I'm sitting here at A, sine of A would be A over C. So this guy would be opposite, adjacent, and hypotenuse, right? So this guy would be A over C for sine. But what if I'm sitting over here at angle B? Like we just said, this guy is now adjacent, this guy is opposite, and my hypotenuse doesn't change. So to get A over C again from this angle, I now have to do cosine. Do you see that? Do you see how the ratio is the same? Okay, so let's look at secant. Secant we decided was, up here at the top, hypotenuse over adjacent. Okay, so secant is a hypotenuse, C, over adjacent if I'm at angle A. So this would be C over B. Whoa, you can't see that, I'm sorry. To get that same ratio, C over B, at angle B, I have to switch to cosecant. Okay, well then let's look at tangent. So tangent is opposite over adjacent, so that would be A over B in my blue ones. But to get A over B again, I've got to switch my angle to B, and I get A over B by doing opposite over adjacent there. Does that make sense? Now listen to what you hear. Sine, cosine, secant, cosecant, tangent, cotangent. What do you notice? It has the co out front, right? So these functions are called co-functional. This is where they get their names. Like before, we're like, well, why didn't you just name sine and cosine? Because they're reciprocals, right? Well, they're not the same function. The co-function means it has the same ratio, but I'm at a different angle. Sine and cosine are both A over C, but I have to go from angle A to angle B. See how they have the same ratio? Secant and cosecant have the same ratio, but I have to go to a different angle. Tangent and cotangent have the same ratio, but I've got to switch angles to get that. tangent and cotangent have the same ratio, but one is at angle A and one is at angle B. So that's where they get their names with the cosine, cosecant, cotangent. That make sense? All right, now let's talk about triangles again for a second. What do you know about all of the angles in a triangle? They add up to 180, right? And if we had a right triangle, what do you know about the two acute angles? They also add up to 90 as well. Okay, so angle A and angle or plus angle B is always equal to 90 degrees. Because angle C is already 90 degrees, right? So angle A and angle B are complementary. All right. So, look down here at example number 2. It says the sine of blank degrees is equal to the cosine of 40 degrees. It's just 50, right? Those two numbers, or those two trig functions, will have the same ratio when their degrees add up to 90. So think about A being 50 and B being 40. Okay, so let's look at the next one. The tangent of y is equal to the cotangent of 90 minus y. Okay. Secant of 67 is equal to the cosecant of 23. 90 minus 67 is 23. All right. Then it says, I hope these page numbers are right. I haven't looked at this. It says memorize the table on page 66. I hope that's the right page. We updated the book. Yes, it is. All right, so there's my table 1 on page 66. Table 1 talks about the exact values of sine, cosine, and tangent for 30 degrees, 45 degrees, and 60 degrees. Table 2 just extends it a little bit, and it takes it for 30 degrees, 0, 30, 45, 60, and 90. All right, let's look at table 2. In fact, on the next page of your notes, I have an exact value chart. So we're going to look at that here in just 1 second. I just want to make sure that exact value chart is on Canvas. It's not. I will make sure it's there. Okay. All right, so look at this guy right here. Let's look at this guy for a second and tell me if you see a pattern or something that you notice. What do you see, Wyatt? Yeah, they're all over 2, right? What else do you notice? Zoe, what do you see?
Sine increases by 1 in the radical each time, and cosine decreases by 1.
Yeah, it sure does. It goes square root of 0 over 2, square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, square root of 4 over 2. Perfect. Thomas?
For the sine 0 degrees and then the cosine 90 degrees, wouldn't they just put 0?
Yeah, exactly. So we're going to do that when we make our exact value chart here in just 1 second. Okay? All right, so what I want you to do is turn the page, and I'm going to show you how to make this chart, because you're going to need to start memorizing these things. Okay? So you should have this chart here on the next page of your notes. This chart is going to come in very handy while you're doing your homework. It's going to be the same thing, except for we're going to put all 6 trig functions on it. Okay? Now, as you notice, we've got some right triangles going on here. We can still use those. Wyatt?
We have this chart when we do
So I'm going to give you a blank one of these when you take your test. Does that make sense? So we're going to make one right now, and I'm going to show you how to make it so you can make it again when you take your test. Good question. Okay, so here we go. As we noticed that the square roots went up by 1, right? So let's do that same thing. Square root of 0 over 2. Well, as Thomas just said, the square root of 0 is just 0. So this first one is 0. It's still blurry. Thanks, you don't think? All right. Now, 30 degrees. Square root of 1 over 2. Ooh, that makes me cringe. Why?
Square root of 1 is 1.
Square root of 1 is 1, so that guy's really a half. Square root of 2 over 2. Well, he's rationalized. He's pretty. I'm going to leave him. Square root of 3 over 2. He's okay, too. How about the square root of 4 over 2?
2 over 2 is 1.
Yeah. This guy, the square root of 4 is 2 over 2, so he's 1. All right, now, let's think for a second. We decided that sine and cosine were co-functional, meaning that if their degrees add up to 90, they have the same ratio, right? So cosine of 0 would have the same ratio as sine of who? 90. Okay, so can I just write these guys backwards? Because 30 and 60 add up to 90, and 45 and 45 add up to 90, and then 30 and 60 and 0, 90. So I'm going to write sine backwards for cosine. So here we go. 1, root 3 over 2, root 2 over 2, 1/2, 0. All right, now, what do you remember about tangent? We've already talked about it. Sine over cosine. Hey, look, it's all set up for me to do that. I can take that guy and divide it by that guy. So 0 divided by 1 is 0. One half divided by root 3 over 2. I'm going to write it so you can see it. Ooh, we're going to have to do some work. We're going to do some copy dot flip in. We could also see how they both have a 2 in the denominator, so I get 1 over root 3. But I can't leave my answer with a radical in the denominator, so how's that guy rationalize? We'll circle, so you know what he is. All right, how about root 2 over 2 over root 2 over 2? 1. It's the same thing on the top and the same thing on the bottom. That guy's 1. Okay. Root 3 over 2 over 1/2. Same denominator, so they cancel. So this guy becomes root 3. And 1 divided by 0 is undefined. Oh, we've got half of it done, right? That wasn't horrible. How can we find cosecant, secant, and cotangent, though? We could flip over sine, right? Sine and cosecant are reciprocal, so we could just flip this guy over. Okay, so if I do that, what do I get for the cosecant of 0? Undefined. Okay, cosecant of 30. 2. 2 over 1 or just 2? Flip over root 2 over 2. Okay, so I'm just going to flip them over, right? And then I rationalize. So that would be 2 root 2 over 2, which then reduces to just root 2. Okay, flip over this guy, 2 over root 3, so if I rationalize, 2 root 3 over 3. And if I flip over 1, he's still 1. All right, now we've got lots of ways we could fill in secant. What's one way we could fill in secant? Zoe, what do you think?
Cosecant and the other one.
Like, just rewrite this guy backwards, right? We could write cosecant backwards because secant and cosecant are co-functional. That's one way. What's another way we could fill out secant? Flip cosine. Perfect. Okay, you decide. I'm just going to write him backwards because he's already rationalized. So 1, 2 root 3 over 3, root 2, 2, undefined. All right, last one, cotangent. What's one way we could write cotangent? Cosine over sine. Flip tangent and write it backwards, okay? I'm probably going to write tangent backwards just because it's a little faster for me. So, undefined, root 3, 1, root 3 over 3, 0. Okay, make sure you've got it. That should be your exact value chart. You will actually need this on your homework. So I would keep this guy handy for you. Now, let me show you why I put the triangles at the bottom. Because sometimes you get stuck, right? Sometimes you're like, oh, Lord, do I start with 0 and then go up? Or do I start with, you know what I mean? That sort of thing. So let me show you the triangles down at the bottom in case you get stuck. So if we say that this guy is 1, using my ratio of sides of a 30, 60, 90 triangle, what would my long leg be? Root 3, right? Or 1 root 3 if you like that. So then what would my hypotenuse be? 2. So if you get stuck, you could say, okay, the sine of 30 degrees would be opposite over hypotenuse. Okay, so if I sit here at 30 degrees, opposite over hypotenuse is 1/2. Is that what we put in our chart? Yeah. You see what I'm saying? So it helps you if you get stuck. All right, so if we look at the ratio of the sides of a 45, 45, 90 triangle, remember the legs are the same. So 1, 1, and then root 2. Now, the only thing that doesn't give you is 0 and 90. You just have to know those ones. Does that make sense? Okay. Questions on your exact value chart, or what we just did there? Okay, so keep that guy handy. I've got mine here. Ooh, I pulled him out, and I didn't mean to. I got my other form here. So, go back to your notes. You are going to, like I said, I don't want to say memorize it, but I want to say memorize how to make it. Does that make sense? So you can reproduce this. I'm going to let you use this on your homework and everything else. All right, so number 3 says, show the following are true by using the exact values. Okay, so here I go. I've got my exact value chart, and it says the cosine of 30 squared plus the sine of 30 squared is equal to 1. All right, well, let's look at the cosine of 30. What's the cosine of 30? Root 3 over 2. And I want to square that. And then what's the sine of 30? 1/2. And I want to square that. And hopefully, when I do all that algebra, sorry, that's hard to see, I should get 1. Okay, so let's see what happens. What happens when you square root 3? 3. What happens when you square 2? So I have 3/4 there. What happens when you square 1? What happens when you square 2? Is 3/4 plus 1/4 equal to 1? Yes. Woohoo! So this one is just like showing you work, right? Just show me that it works using your exact values. Okay, let's try another one. Cosine of 45 degrees. You look at your chart. What's the cosine of 45 degrees? Root 2 over 2. Squared. And then what's the sine of 45 degrees? Root 2 over 2 again. Alright. So if I square root 2, I get 2/4. So 2/4 plus 2/4. Does that equal to 1? Yes, indeed, it does. Okay, questions on any of that? You okay so far? All right, number 4 there says simplify each expression as much as possible if x equals 30 and y equals 45. Okay, so you're just kind of plugging and chugging with your chart. Okay, so here we go. 2 times the sine of 30 degrees. And I'll put parentheses around them if that helps. All right, well, you've got your chart, your exact value chart of 30 degrees. What's the sine of 30 degrees? 1/2. What's 2 times 1/2? 1. Remember, it's 2 over 1 times 1 over 2. Okay, letter B. This is the sine of 2 times y, and y they told us was 45 degrees. So this guy is the sine of 90 degrees. Look at your chart. What's the sine of 90 degrees? 1. Now, they won't give you something on there. They won't say, like, you shouldn't end up with, like, the sine of 75. Does that make sense? You should end up with 30, 60, 90, 45, 0. All those ones, right? So you shouldn't end up with anything crazy that's not on your chart. Okay, here we go. Letter C. 4 times the sine of 3 times 30 minus 90. Holy cats, that's a lot. Make sure I close on it. 0, right? 3 times 30 is 90 minus 90. So this is 4 times the sine of 0. And what's the sine of 0? 0. So this guy's 4 times 0 or just 0. So remember, if you can't draw a triangle in which angle A or angle B is not acute, so if you have anything other than quadrant 1, you have to use x, y's, and r's. Definition 1 is x, y's, and r's. Wyatt.
Will we be using expression in
This chapter, no. So what we're eventually working towards, Wyatt, is that we'll take this exact value chart and we'll spread it across the other 3. So in chapter 3, we'll take this exact value chart and we will put it into all the other quadrants. That's where we're headed. Okay, so number 5 there says find sine of theta, cosine of theta, and tangent of theta if theta is 90 degrees. Got your chart? What's sine of 90? 1. Cosine of 90.
0.
Right? Straight from our chart. Tangent of 90.
Undefined.
Undefined. So you're just going to use that chart a ton throughout your homework. Okay, questions? Jillian.
So why can't we just like continue using x, y, and r?
Why what?
Why can't we just continue?
You still can. Yes, you still can. It's the same thing. We're still just going to go. We just then put it because as we change where it's at in the quadrant, that opposite over is stuff negatives and whatnot. So we're just sort of saying, hey, let's everybody be positive right now. And let's do that. But you can still use that. Yeah, if that makes sense, you're doing the same. Okay. Anything else?